For this question, we're given a diagram in a coordinate plane. We've got this parallelogram broken up into two separate triangles, and our task is to prove that these two triangles, OPM right here and ONM right here, are both isosceles triangles. We need to remember the definition of an isosceles triangle is that it has two sides that are congruent to each other. And so let's figure out the length of the sides of these triangles, and then we'll compare them to see if they really are isosceles triangles. All right, now this horizontal line right here, that's super easy. It goes from 0 to 5, so the length of that is 5. And this one goes from 3 to 8, so the length of that is 5. And let's figure out the lengths of these other sides and this diagonal if necessary. So let's start with this one right here. I'm going to create a right triangle out of this, so I can use that to find the length of this line right here. We have a right triangle. The length of this leg is 3. The length of this leg is 4. And then this side right here will be the hypotenuse of that. So we can use the Pythagorean theorem. We're going to do the same thing with this one. So if I go straight up and straight over, I've created again a right triangle. The length of this is 4. The length of this is 3, and we're trying to figure out the length of that diagonal. So do you notice that we have the two triangles here that really are the same ones, just a transformation of each other? They have lengths of 3 and 4. So if I do the Pythagorean theorem for one of these, I know the other one. And then we can come back to this one if necessary in a little bit. All right, let's take this triangle over here and let's draw it on the board. So we've got our side length of 4, our side length of 3. Here's our right angle, and this side is C. And that's the length that we're looking for. So our Pythagorean theorem gives us 4 squared plus 3 squared, and that's equal to C squared. 4 squared is 16, 3 squared is 9, and 16 plus 9 together is 25. We need to get rid of this square, so we're going to take the square root. And the square root of 25 is a nice number. That gives us 5 equals C. So 5 units. Let's go ahead and add that to this picture. So I now can erase this triangle. I don't need it anymore. The purpose of that triangle was to figure out the length of this side, which is now 5 units. So we can see that this triangle right here has a side of 5 units there and a side length of 5 units there. That gives us our isosceles triangle. This one was exactly the same as before, so I'm going to erase that and put the 5 units in there. So we now have 5 units and 5 units here. So we have 2 isosceles triangles. That's the end of our proof. We have successfully shown that triangle OPM is isosceles because both of these have a length of 5, and ONM is isosceles because these two sides have a length of 5. Thank you.